In this video, you learn how to control a servo motor in Arduino using the servo library. You can find the circuit diagram and the full code linked in the description below. And there's also an article version of it if you'd like to use that instead. So let's get started. We can make use of the servo library that comes built into the Arduino IDE. This gives us access to methods that we can use to control the servo motor. So first, you use the include keyword. So include followed by the name of the library. In our case, we are looking for the servo stage. And then we'll create a new instance of the servo class. So you can say servo and then the name of the class you want to create. In our case, I'll just call this my servo. Then we are going to use the attach method of the servo class to specify which pin we've connected the servo motor to. So I'll say my servo dot attach, and then you specify the pin number you've connected your servo motor to. In our case, we connected to pin 9, so I'm going to specify 9 here. Now let's test out if this actually works by sending a signal to the servo motor and turn it to a certain direction. So I'm going to say my servo dot write. The write method lets you write signals to the servo motor to turn it in a certain angle. So I'm going to use 100 degrees here and then upload the code and see what happens. Okay, so now you can see that the servo motor turns to an angle of 100 degrees. So this works. Now we can just look at an example that shows how you can simulate a sweep motion using the servo motor. So I'll get rid of this line of code because we're going to be working in the loop function. Every other thing is going to remain the same. First, we included the servo library and then we created a new instance of the servo class. And then using the attach method, we specified that the servo was connected to pin 9. Now let's write the loop or create the loop that is going to control the servo to be moving in a sweep motion. So it's going to go from 0 to 180 degrees and then from 180 degrees to 0 continuously. So first, we're going to create a for loop. This for loop is going to start at 0 and then go all the way to 180. And then the second for loop is going to start from 180 and go all the way to 0. So this way, we're going to have a continuous motion of 0 to 180 and then from 180 back to 0. So you can say for int position, just going to use POS for position, and then we're going to say position is less than or equal to 180. Then the increment. So we can use the write method again to increase the position of the servo motor from 0 to 180. So remember that we already have an instance of the servo class here, so we're going to use that. So we're going to say my servo dot write, and then we're just going to pass in the. We're going to add a little bit of delay to this. Now, if you don't add delay, your servo motor is going to be moving rapidly. So with some delay, you can actually see it move from each angle. And then that should be it for the first for loop. Now, the second for loop is just the reverse of the first one. So this one is going to start from 180. So we're going to say in position, report 180. And of course, position is greater than or equal to 0. Now we're going to use decrement. Now we're going to do the same thing here. My servo dot write, passing position as a parameter, and then add a bit of delay to this as well. 10 milliseconds. Now this is good to go. We can just upload the code and see how it works. Okay, now you can see that the servo motor goes from 0 to 180 and then from 180 back to 0. So this is basically how a servo motor can be controlled in Arduino. using the servo library. This is pretty simple to do. All you do is specify where you've attached the servo motor to on the board, and then use the right method to send different signals depending on the position you want to move it to. Now there are a couple of other methods that comes with the servo library, but these two are the basic. If you want to check some of them out, I've linked that in the description below. So thank you guys for watching. If you're interested in reading the article version of this tutorial, it's going to be linked in the description below, along with the circuit diagram and the full code for the project. And as usual, don't forget to like, share, and subscribe, and I'll see you in the next video.